Hey y'all, Mrs. Metzger here. I'm just going to walk you through how to do this new process called completing the square to solve quadratics. So this process essentially puts together factoring and taking the square root into one. So hopefully you already watched the warm-up video, worked through those problems, and got a recap of how to solve with taking a square root as well as how to solve by factoring. This is going to put those together. So for this problem, x squared plus 10x plus 12. So first off, we can't solve it with a square root because there's no way to get x by itself. So our next step to check is, can we factor? So if we pull this out here to factor, we put x squared in the top left, 12 in the bottom right. We multiply those and get 12x squared. So our factors of 12 are 1, 6, or 1, 12, 2, 6, 3, and 4. So the goal is we have to find factors that add to 10. Well, in this case, none of these factors add to 10. So therefore, this is not factorable. So due to it not being factorable, not being able to take a square root, that's what's going to lead us to complete the square. So what complete the square does is it makes this problem factorable. So essentially our goal is we're going to take this x squared plus 10x. We essentially want to figure out what can we turn the 12 into so that we can factor this. And we're going to be able to factor it in a special way. So the first step is we really only care about the variables here. That 12 we want to get out of the way. So instead of setting it equal to 0 like we did with factoring, we want to switch it around so that the variables are on one side of the equation, variables on one side, and numbers on the other. So constants on other. Oh goodness, if I could spell them right at the same time. That should say on other side. I want to make it more easy for you guys to read. Okay, so in this case, that means we want to move this 12 to the other side of the equation, so we subtract it. And that leaves us with x squared plus 10x, and then plus, we're going to figure out something to add to this. So I'm putting that plus blank there. Probably shouldn't have done that until after I explained a little more. But our goal is to figure out how do we make this a perfect square. So what that means, we want to be able to make it so we can factor it to be something times itself. So that way we'll be able to take a square root and solve it like that very first way we solved problems. So we want to figure out what do we have to add so that we can factor it so it's the same parenthesis times itself. So to do that, let's create a little box over here because that's how we factor. We know this x squared goes top right. Our goal is to figure out what goes in the bottom left because that's going to be what we add. So we have to do a little problem solving. We want this to be a perfect square, so we want it to be something times itself, which means these two blocks are going to have to be the same. Because up here we know x times x equals x squared. We want the outside to be the same, so therefore those two blocks have to be the same. Well, those two blocks are the two things that add to 10x. The only thing that can add to 10x, that's the same number, will be 5x plus 5x. So you're always looking for the same number that adds to itself to get to that middle number. So we have a 5x and a 5x, which means our factors are x plus 5 and x plus 5. So we know this is how we'll create a perfect square with that 10x in there. So now we just have to figure out what goes in that purple circle. Well, if we look at our box, we multiply 5 times 5. That means we have 25. So if we have x squared plus 10x plus 25, that completes our box method over here on the left. And then the factors that give us that are x plus 5 and x plus 5. So we're kind of having to problem solve with our box method. So that means if we simplify this out, factors to x plus 5 plus x plus 5, well, that's the same as saying x plus 5 squared. And now whatever we add to one side of the equation, we have to add to the other side of the equation. So now if we simplify this out, negative 12 plus 25 is a positive 13. So to put this into steps, our first step was to get our variables on one side, constants on the other. The second step was to do this new process called complete the square. So we wanted to complete the square so that we could rewrite it right as parentheses with a square on the outside. So now there's kind of a little shortcut to that process. You can use that box to help you out. But notice, if we're looking for something to add to itself, essentially what we're always going to have to do is take this middle value, divide it by 2. So that's really where that 5 came from. So a lot of times you'll see b divided by 2. Because notice that, think ax squared plus bx plus c. And then what we do with that number to figure out what adds to both sides is we square it. So a lot of times you'll see we have to do b divided by 2 squared to figure out what to add to both sides. And then in the process, when you square it, this in the parentheses here, that's just your b over 2. So hopefully that just didn't over confuse you. But that's that new process called completing the square. So now, last step. This now looks like the problem we started with. To get rid of that square, we take a square root. So take the square root of both sides. We get x plus 5 is plus or minus the square root of 13. Square root of 13 cannot be simplified, so we just end up with plus or minus square root of 13 minus 5, because we have to subtract 5 from each side of the equation. And there is our final answer. So in your workbook, this is totally worked out for you guys to look at. I believe it's page 83. You're looking at activity 5.2, and it'll work out this problem. I'll go ahead and make one more video after this to work through the 2 example problems on the next page in your book. But first, try them on your own, try and follow these steps, and then use that video to check your answers. Feel free to email me if you have any questions as you work through. Good luck. Hopefully you can make some sense of this. See you guys.